All right, welcome back, young scientists. Here we are in our last unit. We're going to talk about acids and bases. A quick review of some things you hopefully already have mastered. Acids and bases are going to be talking essentially entirely about solutions. Remember, solutions are homogeneous mixtures, which means their components are evenly distributed throughout. All of our homogeneous solutions here are going to be aqueous, meaning they are dissolved in water. And we're going to be referring to molarity quite a bit, as in the moles divided by the liters of solution. Remember, capital M is our unit for molarity, and we're going to have moles and liters as our other units to calculate it. Just as a quick review, there are two practice problems here. The first one, what's the molarity of a solution made from dissolving 50 grams of sodium chloride into 500 milliliters of water? Things to look at here, you're going to need to get the 50 grams of sodium chloride into moles, and the 500 milliliters, remember that's half a liter of water, and then you'll divide. You can go ahead and pause the video and practice that if you like. Then we also have our second one here, how many grams of lithium chloride are required to create 400 milliliters of a 0.5 molar solution. So if you need a little help, go back and look at that triangle in the equation on the previous slide. Again, you can pause the video and solve this at your leisure. A new equation, but a pretty simple one, is our dilution equation. When we dilute a solution, we are adding water to it to make it less concentrated. So, like when I'm in the lab, I get from the factory very concentrated solutions like 16 molar hydrochloric acid. Obviously, I'm not going to hand that to you guys because it's pretty dangerous. So I'll dilute it down to 6 molar, 4 molar, 2 molar, 0.1 molar as needed. Our equation here is the initial concentration, M1, times its volume is equal to the final concentration times the final volume. So M1V1 equals M2V2. So here are a couple of example problems. The first one reads, how many milliliters of 12 molar hydrochloric acid are required to make 500 milliliters of 6.0 molar? And the second one reads, how many milliliters of 18 molar sulfuric acid are needed to make 250 milliliters of 0.5 molar sulfuric acid? Again, you can pause the video to go ahead and try these out yourself. When you're ready, unpause, and we'll move to the next slide. Okay, looking at that first problem, how many milliliters of 12 molar HCl are required to make half of a liter or 500 milliliters of 6 molar? So we'll say our first volume, and which one you call first is really irrelevant. 500 milliliters times 6 molar equals V2 times 12 molar. So then I'm just going to divide both sides by 12 and say 500 times 6 over 12 equals V2. And V2 is 250 milliliters. Note, whatever unit of volume I use on one side is going to be the unit that I get on the other side. So if I had done this calculation in liters and said half a liter, my V2 would have been a quarter of a liter, 0.25. Second problem, how many milliliters of 18 molar sulfuric acid are needed to make 250 milliliters of 0.5 molar? So we say 250 milliliters times 0.5 molar equals V2 times 18 molar. Divide both sides by 18. And we're going to get, it's really like 6.94, but we'll round that and say 7 milliliters is our V2. Then real quickly, I just want to run you through some general properties of acids and bases. These are things we can look at to describe them. Acids in general taste sour when you think about things like vinegar or citrus. Vinegar is really acetic acid, and citrus contains lots of citric acid, and these are what give them their sour flavor. Acids are highly corrosive, which means they're very reactive with a number of things that will break them down. One of the things they'll react with is basically any metal to make the metal ion and some hydrogen gas. Acids are what we call proton donors or H plus ion donors. We'll talk more about that in the next video. They will neutralize bases. They will react with bases to make a neutral solution. If you use litmus paper, which you may have done in a previous class, on an acid, it will turn it sort of red or yellow depending on how strong it is. And when we talk about the pH scale here coming up, it's going to be numbers below 7. Then also talking about bases, it's basically, no pun intended, I'm so very sorry, going to be the opposite. Bases typically have a slippery feel to them. This is especially noticeable in things like soap or even like Windex. They have a bitter taste. So like if you have Tums, you'll notice that they're pretty bitter to the taste. These are hydrogen ion acceptors or proton acceptors. They are also very corrosive. They will react with a large number of things to break them down. People think about acids as being the only dangerous one, but a strong base is equally as dangerous as a strong acid. They will neutralize acids to make a neutral solution. They're going to change your litmus paper more blue or even purple, and they are the numbers greater than 7 on the pH scale. So this was a basic overview of acid-base chemistry. We'll go into some nomenclature as well as pH calculations on the next screencast.